In the last video, we looked at quite a few meta-characters. For example, we saw meta-characters to match a word character, a digit, and a space. And conversely, there are meta-characters that match anything not a word, digit, or space, respectively. We also saw character classes, quantifiers, and the concept of look behind. At this point, perhaps your mind is buzzing. Mine certainly is. So at some point we will organize these meta-characters into logical groups. But that time is not now. So in this video we will continue building upon our repository of meta-characters and looking at tackling an often encountered problem when dealing with text, the double word problem. But let's start with a question. I have a string and I wish to match its entire content. The string may have alphabets, numbers, or other characters. I do not care. I just wish to match the entire string. How do we do that? The meta-character dot matches any character. Let's see how it works. This pattern matches the entire string. Great. But can we have a more useful example? A common problem is searching for dates in a string. So let's say we know that dates are in DD, MM, YY format, but we are not sure about the separator. It could be a dash, a forward slash, or a dot. How do we handle this? One way is to use character classes like so. Notice the dash at the beginning of the character class. But can we simplify? Let's try another pattern. That works too, but wait a minute. How is the dot outside the character class different from the dot inside the character class? The dot inside the character class is treated literally. The dot outside the character class is a meta-character, so matches any character. Please pause the video and ensure this point is clear. So stretching this discussion further, we may argue that this pattern is more simple, but on the flip side, it may have an undesired result. Consider a string like so, representing say a lottery number. It will get matched too. So which pattern should we use? It all depends on how specific we wish to be. We have seen a few examples of character classes by now. But there is one more pattern, a negative character class. Let's take an example. I wish to find words that start with a Q, but the second character should not be a U. Can you think of such words? Let's try it out. Ignoring these interesting words for a moment, we have just used a negated character class. But there are two problems with the solution. Firstly, I do not really care about case, so I would want to see this last word too. Let's fix this by adding a parameter to our function. Great. But I still want to find words. The QI here is part of the word Iraqi. How to fix it? Well, we will wrap our pattern in a word boundary like so. Let's test. That blew things up, hey? It turns out that the \b is also used as the backspace control sequence. Thus, in order for the regular expression engine to interpret the word boundary correctly, we can use a raw string literal. Please allow me to not get into more detail here. We have made a case for the raw string literal, and we will encounter it again in the future and again discuss it. At this point, let's throw in a question. How would you match a pattern such as July? The only problem here is that we could have July written both as JUL or JULY. Pause the video and try it out. So here's one solution using a quantifier. We are approaching the end of the video, but before leaving, let's look at one last problem. Double words is a very common problem. Can we use regular expressions to detect double words? So in this simple example, we have two double words. What we need to do is firstly remember each word in the pattern and see if it is repeated. We will use two new concepts here, a parenthesis and a concept called a back reference. In many regex flavors, the parentheses or parenthesis can remember text matched by the sub-expression they enclose. And how do we access that remembered text? By using back referencing. So in this case, we have one parenthesis. To access its contents, we will use a special meta sequence \1, which represents the text match within the first parenthesis. Whatever it is at that point. Let's test. All good here? So in conclusion, we saw many more meta characters in this video: character classes, negated character classes, the dot meta character, the ignore case parameter, word boundaries, parentheses, and back referencing. Please practice each of these concepts so that it gradually sinks in. Thank you, and see you in the next video. Just one more thing, guys. If you want access to practice exercises and quizzes, click on the description to find a link to my Udemy course on regular expressions. Thanks a lot.